Astrophysics is a fascinating field of study that seeks to understand the properties and behavior of objects in the universe that are far beyond our daily experience. Recently, NASA has made a discovery that is both incredible and terrifying at the same time. The space agency has found an object that is consuming galaxies, and it is doing so at an alarming rate. In today's video, we will explore what this object is and how NASA discovered it. You see, galaxies are massive structures in space that contain billions of stars. From Earth, we can see many galaxies in the night sky, including our own Milky Way galaxy. These galaxies are typically several thousand light years across and can contain anywhere from hundreds of millions to trillions of stars. However, NASA has discovered a massive object that is so large that it is consuming entire galaxies. This object is called a black hole. What could the implications of this discovery be, as it is one of the most mysterious and powerful forces in the universe? These and more will be explained in today's video. However, before we continue, take a moment to like this video and subscribe to my channel. Without much ado, let's dive in. Let's start with an astrophysical concept called the active galactic nuclei, AGN. What are active galactic nuclei, AGN? Active galactic nuclei, AGN, are some of the most energetic and powerful objects in the universe. They are located at the centers of some galaxies and emit a tremendous amount of energy across the electromagnetic spectrum. AGN are powered by the accretion of material onto supermassive black holes, which heats the surrounding gas and causes it to emit radiation. The radiation from AGN can be so intense that it outshines the entire galaxy, making it one of the brightest objects in the universe. AGN are characterized by their spectral properties, which show strong emission lines that are indicative of the presence of ionized gas. This gas is heated up to high temperatures by the accretion disk surrounding the supermassive black hole. The intense radiation emitted by AGN can also produce jets of particles and radiation that are ejected from the black hole at near-light speeds. These jets can extend over millions of light years and are visible across the electromagnetic spectrum. AGNs are classified into different types based on their spectral properties. The most common type is known as a Seyfert galaxy, which emits a relatively low level of radiation and is characterized by narrow emission lines. Another type of AGN is known as a quasar, which emits a much higher level of radiation and is characterized by broad emission lines. Blazars are a type of AGN that emit high-energy radiation and are characterized by variable emissions across the electromagnetic spectrum. AGNs are of great interest to astronomers because they are believed to play a significant role in the evolution of galaxies. The intense radiation emitted by AGN can heat up and push out flows of gas from the galaxy, effectively quenching star formation in the surrounding regions. This means that the supermassive black holes at the centers of galaxies have the potential to regulate the growth and evolution of galaxies themselves. The supermassive black holes. Supermassive black holes, SMBH, are incredibly dense objects that exist at the center of most galaxies, including our own Milky Way galaxy. They are characterized by their enormous mass, with masses ranging from millions to billions of times that of the Sun. SMBs are believed to form through the accretion of matter onto smaller black holes, and they continue to grow by accreting gas and other material from their surroundings. And the SMBs are crucial to the functioning of AGN, as they are the primary source of energy that powers the intense radiation emitted by these objects. The gas and other material that falls into an SMBA forms an accretion disk around it, which heats up and emits radiation as it spirals inward. The energy released in this process can be orders of magnitude greater than the energy produced by all the stars in the galaxy combined. Despite their enormous mass, SMBAs are extremely small in size, with an event horizon, the point of no return for anything falling into the black hole, that is only a few times larger than the Sun. This makes them incredibly difficult to observe directly, as they do not emit any radiation themselves. Instead, astronomers must rely on indirect methods to infer the presence of SMBAs, such as the motion of stars or gas in their vicinity, or the gravitational lensing of light passing nearby. One of the most intriguing aspects of SMBAs is the role they play in the evolution of galaxies. The accretion of gas onto SMBAs can heat up and eject gas from the galaxy, effectively regulating the growth of stars and influencing the formation of structures such as galactic bulges. This means that SMBAs have the potential to shape the evolution of galaxies themselves, and understanding their properties and behavior is crucial to our understanding of the universe as a whole. NASA has been at the forefront of research into SMBAs and their role in the universe. In 2019, the agency released the first image of the shadow of the SMBA at the center of the galaxy M87, which was captured by the Event Horizon Telescope, EHT, a network of radio telescopes around the world that was specifically designed to observe black holes. This image provided strong evidence for the existence of SMBAs and confirmed many of the predictions of Einstein's theory of general relativity. The role of supermassive black holes in AGN. Supermassive black holes, SMBAs, play a critical role in the formation and behavior of active galactic nuclei, AGN. The accretion of material onto SMBAs generates a vast amount of energy, which heats up and ionizes the surrounding gas, producing the intense radiation that characterizes AGN. In this section, we will explore the various mechanisms through which SMBAs influence the behavior of AGN. Accretion disk. The accretion of material onto SMBAs forms a disk of gas and dust around the black hole, known as an accretion disk. This disk is heated up to temperatures of millions of degrees, causing it to emit radiation across the electromagnetic spectrum. The intense radiation from the accretion disk ionizes the surrounding gas, producing the emission lines that are characteristic of AGN. Outflows. The radiation emitted by AGN can also generate outflows of gas from the galaxy, which can have a significant impact on the surrounding environment. The outflows are driven by radiation pressure and can eject gas from the galaxy at speeds of up to several thousand kilometers per second. The outflows can also suppress star formation in the surrounding regions, effectively quenching the growth of the galaxy. Jets. Some AGNs are also associated with powerful jets of particles and radiation that are ejected from the SMBA at near-light speeds. These jets can extend over millions of light years and are visible across the electromagnetic spectrum. The origin of these jets is still not well understood, but they are believed to be produced by the interaction between the SMBA and the surrounding magnetic fields. Feedback. The energy released by SMBAs can have a significant impact on the evolution of the host galaxy. The outflows and jets produced by AGN can regulate the growth of stars in the surrounding regions, effectively controlling the rate at which the galaxy forms new stars. This process is known as feedback and is believed to be a crucial factor in the evolution of galaxies. The role of SMBAs in AGN is an active area of research, and NASA is at the forefront of studying these objects. One of the agency's most significant contributions to the study of AGN is the Chandra X-ray Observatory, which is designed to observe high-energy radiation emitted by AGN. This observatory has provided many insights into the behavior of AGN, including the role of SMBAs in producing jets and outflows. The study of SMBAs and AGN is an essential area of research in astrophysics, and continued observations and theoretical modeling will undoubtedly yield many new insights into these mysterious objects. NASA's discoveries. NASA has made many significant discoveries in the study of active galactic nuclei, AGN, and the role of supermassive black holes, SMBAs, in powering these phenomena. One of the most significant contributions is the discovery of SMBAs in the centers of galaxies. This discovery provided strong evidence for the existence of SMBAs and opened up a new field of research in astrophysics. NASA's Chandra X-ray Observatory has provided many insights into the behavior of AGN. By observing high-energy radiation emitted by AGN, Chandra has helped to reveal the accretion disks and jets produced by SMBAs, as well as the outflows of gas and the impact of feedback on the evolution of galaxies. This information has been instrumental in advancing our understanding of AGN. In 2014, NASA's Hubble Space Telescope discovered a massive outflow of gas in a distant galaxy, which was caused by the intense radiation emitted by an SMBA at the center of the galaxy. This outflow, known as quasar feedback, was found to be capable of regulating star formation in the galaxy and could help to explain why some galaxies stop forming stars early in their evolution. NASA's Wide Field Infrared Survey Explorer, WISE, has discovered a new class of AGN known as Changing Look AGN. These objects are AGN that has dramatically decreased in brightness in the past few decades, suggesting that the accretion of material onto the SMBA has decreased significantly. This discovery challenges our current understanding of AGN and the behavior of SMBAs. NASA's Nuclear Spectroscopic Telescope Array, new STAR mission has discovered a new class of AGN known as ultraluminous X-ray sources, ULX. These objects emit X-rays at rates that exceed the Eddington limit, which is the theoretical limit on the amount of radiation that can be emitted by an object before it collapses under its gravity. The discovery of ULX has challenged our understanding of the behavior of SMBAs and the accretion of material onto them. In conclusion, NASA's discoveries in the study of active galactic nuclei, AGN, and supermassive black holes, SMBAs, have greatly advanced our understanding of the universe. By observing the behavior of AGN using advanced telescopes and spacecraft, NASA has revealed the complex processes that occur at the centers of galaxies and how they influence the evolution of these systems. From the discovery of SMBAs to the study of quasar feedback and changing look AGN, NASA's contributions to this field have been crucial in shaping our understanding of the universe. As technology and scientific methods continue to advance, we can expect even more groundbreaking discoveries in the study of AGN and SMBAs. By continuing to push the boundaries of our understanding, we can gain a greater appreciation of the complex and mysterious universe we live in. NASA's work in this field will undoubtedly inspire future generations of scientists to continue exploring the depths of space and uncovering the secrets of the universe. Thank you for joining us in this exploration of NASA's discoveries about active galactic nuclei and supermassive black holes. Through NASA's groundbreaking observations and missions, we have gained a deeper understanding of these mysterious phenomena and their role in shaping the evolution of galaxies. Make sure to subscribe to our channel for more exciting science content and leave a comment below with your thoughts and questions about AGN and SMBAs. See you in the next video.